Okay guys, so this is a run through of the June 2018 paper 2F from Pearson exam board. Okay, so we've got here a question that says write this as a percentage, so we should recognise that percentage means out of 100, so we've got 4/50ths is equivalent to something out of 100, so we times by 2, 8, so the answer is going to be 8%. Now this is a calculator paper, so you could have done on your calculator 4 divided by 50 times 100. That would also give you an answer of 8. So either way you'd get 8%. This one says write this correct to one decimal place. Well, this means the number of digits after the decimal point. So in this case we want to have just one digit after the decimal point, so we're literally asking ourselves, is this more than halfway to the next tenth? So 5 or more, this goes up by 1, so it becomes 1.6. So the answer to that, 1.6. This question talks about work out the value of 3 to the power of 5. Well, on your calculators you should recognise that you've got a power key. Now on some calculators it looks like Y with an X, on some calculators it's X with a little box, and so forth. On this calculator it is X with a little box. So literally we're going to type 3 to the power of 5 and then press enter. So 243. So the answer here, 243. It is a calculator paper, so make sure you know your calculator keys. And if you have that key, then you'd have pressed 3, Y with the X, 5 equals, and that would have given you 243. Okay, the question goes on and it says write down a 6-digit number that has 4 as its thousands digit, and you can only use the digit 4 once. Okay. So a 6-digit number, 1, 2, 3, 4, 5, 6, and it wants it in the thousands place. So we know it goes units, tens, hundreds, thousands, so that's where the 4 has to go, and literally you can put any other digits in there apart from 4. So 1, 1, 1, 1, 1. It really didn't matter as long as you had the 4 in the thousands column. Okay, so this question is about converting units, and if you haven't watched my video on all the facts and things that you need to know for GCSE maths, then it might be useful because it will remind you about all these conversions, not just these but other ones that you need to know. So with this we need to recognise that 1 centimetre equals 10 millimetres, so we're doing 35 times 10, so we end up with 350 millimetres. This one is about millilitres to litres, so we need to remember that 1 litre is equivalent to 1,000 millilitres, milli meaning a thousandth, so there's 1,000 of them in a litre, so we end up doing 7,700 divided by 1,000. Again, do this on your calculator guys, but it's going to be 7.7 litres. And this one wants you to do kilograms to grams. Well, anything beginning with kilo means 1,000. So 1 kilogram is equal to 1,000 grams. So we're going to do 0.32 times 1,000 because we're turning kilograms to grams. So we're going in this direction, kilograms to grams. So times by 1,000. And again, you do it on your calculator, but you'd end up with 320 grams. Okay, so learn your conversions, guys. Okay, so here we've got the classic somebody's thinking of a number type problem. So she says number's odd, it is a factor of 36 and a multiple of 3. There are 2 possible numbers. Right, okay, so this is saying a factor of 36, so the first thing we should do is write down all the factors of 36. So every whole number starts with a factor of 1, and then you start going through. 2 is definitely in there because it's even, 3 is definitely in there because it's a multiple of 3, 3 is in there, 4 is in there, 6 is in there, 9 is in there because 4 9s are 36, 3 12s are 36, 2 18s are 36, and obviously 36 times 1 is 36. Multiples of 3, and it's got to be odd. So that's a multiple of 3 and odd, that's a multiple of 3 and odd, and lots of multiples of 3, but those are the only 2 that are odd. There are 2 possible numbers that she's thinking of. Write down these 2 numbers. Well, we've identified 3 and 9. Okay, so the answer to this question would be 3 and 9. Okay, so we've got some people that are going to play a game, and so one will be in first, one will be in second, third. Use tail to list all the possible outcomes. Okay, so we'll call Mohsin M, Yusuf Y, and Luke L. That's a classic way of doing these problems. So we do this with logic. So Mohsin could be first and followed by Y and L. Could also be first but then followed by LY. Yusuf could have been first followed by the other two. Could be first followed by the other two in a different order. Luke could have been first followed by the other two. And again, Luke could have been first with the other two in a different order. So that would have been the answer to that question. Just doing it logically, and you're just using letters to save writing the whole names all the time. So those could be the possible outcomes in terms of who could have done what. Okay, so we've got a problem here about buying stuff. What is the total amount of money he spends? And he's going to buy 30 pens, but it says there's 6 for 82p. So 30 divided by 6 is going to be 5 lots of 82p. Buys 30 pencils. Well, they're 15. So for the pencils, we're going to do 30 divided by 15. So 2 lots at 45p. And 30 pencil cases, and the pencil cases are 37 pence each. Right, okay. So pens, we're doing 5 times 82p, which is £4.10. Then we're doing pencils, and we wanted 2 lots of those, so it's 2 times 45p, which is £0.9, 90p. And then we're doing pencil cases, which is 30 times 37 pence. So that's going to be £9, £11, 10p. And then when we add those together, we'll get the total cost that he spent. So £4.10, £5, £16, so £16 and 10p. Now you'd use your calculators, guys, and hopefully you get the same answer. Again, go through the question, and we read, and we want rulers as well. Okay, so we need rulers as well. And they're 10 for £1.25. So rulers, we're going to do 30 divided by 10. So we need 3 lots. So for rulers, it's going to be 3 times £1.25, which is £3.75. So we add those together, so £19 and 85p. Okay, so that would be the final answer to that question. Again, it's important you go back and read through, because I'd missed out the rulers, so I've gone back and checked, and I'll make sure I've done everything I needed to do. Okay, so we've got here average speed, so we know that's a formula. So average speed is equal to total distance divided by total time. And they're telling us that it's 186 miles is the total distance. We're dividing by 3 hours, so that's going to give you 62 miles per hour. So that's the answer to that question. She drives at an average speed of 58 miles for 4 hours. How many miles does she drive? Well, what we've got to realise that speed, distance, time, so distance divided by time. And if we want to know how many miles, then we want the distance, so cover that up. It's telling us to do the distance is equal to the speed times the time, which makes sense, because if you're doing 58 miles in 1 hour, then you're going to do 4 times that in 4 hours. So it's going to be 58 times 4, so 232 miles. Again, be consistent with your units, because this is about miles per hour for so many hours, so the units are working in miles. Okay. So here we see a question that talks about prime numbers. So as soon as we see prime numbers, we should be thinking of two factors only. All numbers that are prime have two factors only. So if we list out a few of them, so the first prime number is 2, 3, 5, 7, 11, 13 and so on. All of those have two factors, 1 and 2, 1 and 3, 1 and 5 and so on. Basically it's 1 and the number itself. The only factors I'll go into. But it wants you to write down the prime numbers between 20 and 30. So if we carry on from 20, 21 is not a prime number because it's in the 3 times table as well, so it has at least 3 factors. 22 is even, so it has 2 as a factor as well as itself and 1. 23, yep, only has 2 factors, 1 and 23. 24 is even, so it has a factor of 2. 25 has a factor of 5, 26 factor of 2, 27 factor of 3, 28 factor of 4, 29 only 2 factors, 1 and 29. So it'd be 23 and 29. Okay, Catherine says 2 is the only even prime number. Is she right? Yes, she is right. Yes, as all other even numbers have at least 3 factors. Prime numbers only have 2 factors. Okay, so that's how that would be answered. Alright, so we've got some solve questions here. So it means we've got to find the value of x. So we know that when we add the same number 3 times we get 51. So this is saying 3 x's are going to be worth 51. So if we divide by 3, it'll tell us the value of 1x. So x is going to be 17. And if we checked by adding 17, that would work. Remember, use your calculators if you need to. Now this says some number divided by 4 is worth 3. So if we reverse that, then y must be 3 times 4. So 12. And if we check, 12 divided by 4 is 3. So that's why it's going to be 12. And when you're solving, you literally think of doing the opposite operations to move things from one of the sides across the equals to the other side. So this said divide by 4, so on the other side it would be the same as times it by 4. This one says solve this, so we're going to want to leave f on its own. So we need the 7 and the 2 to be on the other side of the equals. So the first thing we do is the term that's not attached to the subject. So we're going to take away 7 to make that 0. We must balance it though. So 2x are going to be worth 11. We want to know what 1f is, so we divide by 2 to get 2 to become 1. So 2 divided by 2 is 1f, and 11 divided by 2 is 5.5. So those would be the answers to those. This question is asking us to draw a pie chart, which means that we need to work out the angles, and we then need a protractor to draw the angles. So we go through then thinking about, well, a pie chart is about 360 degrees, and we're going to share that by the number of items altogether. So we got 8, 25, 36. So the 36, because 11 plus 17 plus 8 equals 36 items. And if we do that, we get 10 degrees. So 10 degrees per item. So literally what this is asking us to do then is times all of these by 10. So that's 110 degrees, that's going to be 170 degrees, and that's going to be 80 degrees. And if we add those up, it would come to 360 as a check. So what we've got to remember when we draw this pie chart is that we always line up a 0 with the line from the centre to the outside, and we always go upwards in terms of counting round. So when we want to do 110 degrees, it's not this 110, because that would be counting down. We're going to use the outside scale, so we're going to come round until we get to 110 and put a dot, and then we're going to draw from the centre to that dot, but only to the outside of the circle, because obviously we're drawing a pie chart, and we're going to label it. So that would be burger and 110 degrees. You wouldn't normally put the degrees in, but tell the examiner what you're doing. That means we now measure the next angle, which means we move our protractor around and we put the 0, so the centre of the protractor on the centre, put the 0 on there. Again, we're going to count upwards, and the next one is 170 degrees, so 10, 20 all the way around until we get to 170, and we join that together, label it, and 170 degrees, label the other one, hot dog, and 80 degrees. Okay, so the thing we draw in pie charts then is it's all about finding out how many degrees per item. In this case we had 36 fans that needed to be put in to this pie chart, and 10 degrees per fan, and so we work out the degrees for each one, and we went through and then drew it accurately, and that's how the pie chart would look. Don't need to colour it in or anything, guys. It's an exam, so don't spend time doing stuff that won't get you marks. Just make sure you label, really important, you label these things, and you measure your angles accurately using a protractor. Okay, so this question talks about they're having a raffle and there's one prize to be won. She buys 12 raffle tickets and there's a total of 350. Find the probability. Well, as soon as you see that word probability, very often in exams you're thinking of a fraction, and basically the fraction is the number of successful outcomes over the total number of outcomes possible. Well, the number of successful outcomes was 12 raffle tickets bought, and the total number of possible outcomes was 350. There was a choice of 350 raffle tickets. So it says find the probability that she did not win the prize. Well, there were 12 chances of winning, so this is win. So we take 350, take away the 12, 338, so there'll be 338 chances of her not winning. So the probability of that happening is 338 over 350. So that would be the answer to the question. Okay. Again, going through, reading through, making sure we're actually doing what the question wanted. Okay, so here we've got a frequency tree, and it's given us some information and it wants us to complete the tree. So it's telling us that 22 of the 45 workers are male, so if we take the 22 away from 45, it's telling us that the 23 are female. 16 of the 34 right-handed workers are female, so this sentence is telling us that 18 are male. Okay, so we've got 45 to start with, and we're splitting up into male and female. Well, they told us that 22 are male, so 23 were female. It said 16 of the 34 right-handed were female. So 18 right-handed males, 16 right-handed females. Well, coming into this part of the diagram we had 22 males, 18 of them are right-handed, so 4 would be left-handed. 23 coming in here, so 16 of them right-handed, 7 of them must be left-handed. So to get that we did 23 minus 16, and to get that we did 22 minus 18. So we used the information that they gave us. Learn these guys, because quite often they then give a part B on this question where they ask you to do a probability. And that's a case of finding the item that's in here that you need, and then do it over 45 maybe, or do it over 23 if it just talks about females. You know, you've just got to read the information carefully. Okay, so we've got to work out the size of angle x, and she writes x equals 63 because the base angles of an isosceles triangle are equal. Well, yeah, that is the correct rule, but the rule says it so that the base angles that are equal are at the end of each of the lines that are the same length. So we can see that the lines go in that direction for the same length. So this is actually 63 degrees, and x would be 180 minus 63 minus 63, which is 126, so 54 degrees. So basically Mary is wrong, explain why. X is equal to 54 degrees, not 63 degrees. That's one way. It's only worth 1 mark, so they're not expecting to do a lot. Or the angle at A is 63 degrees to be the base angle. You could have said either as a mark to get 1 mark, So you go for whichever method you prefer, really. This question goes on about angles in parallel lines, and it says he needs to work out the size of angle Y. Well, funny zebras cross the road. So parallel sides of the road, funny zebras crossed, and then we're looking for these, and what we can see here is we've got a backwards C made with the parallel lines, which means that Y is equal to 180 degrees minus 57 degrees, so 123 degrees. Co-interior angles are equal. Sorry, co-interior angles add to 180. So co-interior. Okay, so we know that the answer should be 123. So let's have a look. 57 because corresponding angles are equal. Well, that's if it's corresponding, we'd be looking for the F. So corresponding. So we'd be looking for creating an F. Well, we'd have to go down here to create the F. So this would be 53 degrees. This one says Y equals, so you take that, Y equals 120, because angles on a straight line add up to 180. Well, yes, because if we know that's, 57 degrees there, not 53. Not sure where I got 53 from, but yeah, 57 degrees because they're corresponding in the same position of an F made with parallel lines. One of William's reasons is wrong, write down the correct reason. Okay. Okay, angle EGH. 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 57. Well, yes, that is 57 because it's alternate angles. So that one would be the correct one from this, although technically they should have argued that the 180 minus 57 is because you've got alternate angles are equal, and then you're doing the angles on a straight line out to 180. So lots of ways of thinking about that. Okay, so we've got a table of information here. It's about bags of buttons, and it's telling us that there are 19 buttons or 20 buttons or 21 in each bag. The table gives some information about the number of buttons. The total number of buttons is 320. Complete the table. Okay, so this is telling us that one bag. So 1 times 22 is 22 buttons. This is telling us there's 3 bags, so 3 times 22 is 66 buttons. This is telling us there's 7 bags, so 7 times 20 in each bag is 140 buttons. So total so far. So we're going to add up those, and we're going to find we get 8, 10, 12, so 228 so far. So they're telling us the question of 320 altogether. So we're going to do 320, take away 228, 72, 92, so 92 buttons in the bags with 19 in each. So we have to do 92 divided by 19. 4 19s. That's interesting. What have I done wrong? 122 is 22. 322s. No, that's not 22. That's 21. Silly boy. 321s are 63. And 720s is 140. So we've got 5. Right, so 5. 10, 12, 2, 1, 225. So we're going to take away 225. 75, 95. So we do 95 divided by 19, which is 5. So 5 bags. So that's the answer. I knew I'd done wrong because 19 does not go into 92. So again, it's a check, isn't it? Because we know this is a whole number of bags. So it says complete the table. So we're going to put a 5 there to complete the table. Okay, so that's how that question could be done. Okay, so list of ingredients for making 30 biscuits. Okay, it's asking us to work out what is the greatest number of biscuits that can be made. Okay, so 900 divided by 225. Right, okay. Alright, lots of ways of doing this, but I'm going to work out how many grams per biscuit actually. So I'm going to do 225 divided by 30. So 225 divided by 30, 7.5. So here I'm going to divide by 7.5 because it wants the greatest number of biscuits. So I'm not working in lots of 30, I just want to work out how many biscuits I can get. So 900 divided by 7.5 is 120. Caster sugar, 110 divided by 30 equals, so I'm going to divide by 3.6 recurring. So 1000 divided by the previous answer, so 272. Plain flour, I'm going to do 275 divided by 30. So 275 divided by 30, so 9.16 recurring. So I'm going to do 1000 divided by 9.16 recurring. So 1000 divided by 9.16. So about 109 biscuits. And 75 divided by 30 is going to be 2.5 grams. So I'm going to divide that by 2.5. So 225 divided by 2.5 is 90. Okay, so what we've found is that 225 grams of chocolate chips will make 90 biscuits. And when we look through this, yes, it says here we could make 272 biscuits, but we have a limiting factor. For chocolate chips, we can only get enough to make 90 biscuits. So when it says what is the greatest number, the answer will be 90 biscuits. Now what I did there was I worked out how many grams of each item per biscuit. So I did grams per biscuit. That's one way of doing it. You could have seen how many 225s go into 900, how many 110s go into that, how many 275s go into that, how many 75s go into that, and then that would tell you again the limiting factor. And what you would have found if you'd have done that method is when you did 225 divided by 75 for the chocolate chips, you'd have found the answer there is 3. So 3 lots of 30 biscuits max, which is 90 biscuits. So again, you know, it doesn't matter which method you use, you would have ended up with 90 biscuits as your limiting factor. So that would be the answer to that question, 90 biscuits, by finding out what limits the possibilities. Okay, so here we've got a transformation question. So as soon as we see the word single transformation, we should be thinking to ourselves then, is it a reflection, a rotation, a translation, or an enlargement? So it has to be one of those. Now we can see that the two shapes haven't got bigger or smaller, so it's definitely not an enlargement. A translation keeps the shapes in the same direction. Well, they're going in different directions. They've flipped over or they've reflected over, so it's definitely not a translation. It's not a rotation, because if it was a rotation then this shape would be pointing in a different direction, but it would be going round, so it'd be kind of pointing, it'd be kind of doing that if it was rotating, and if it came downwards it would be kind of doing that. So it's not a rotation, so it's definitely a reflection. So we're going to have to say reflection for 1 mark, but we notice the question's worth 2 marks, so it's asking us to also say what is the line of reflection. So a reflection, we just measure the distances between them and go halfway, and we can see here that halfway would be the y-axis, so a reflection across the y-axis would get you 2 marks. You could have also said, though, because this line is also known as the x equals 0 line, so reflection across the y-axis or the line x equals 0, either of those would have been acceptable. Okay, so we've got a farmer, shape of a semicircle, and it has a diameter of that. It wants to build a fence around the edge. Okay, so the edge, well, it's shouting out at us, isn't it, that it's talking about the circumference. And we know the circumference of a circle. If we've learnt our circle song, now if you haven't listened to it, guys, do listen to it. It's on the YouTube. Just type in circle song and it should be your first hit, and it'll come up with a little chorus line that says pi r squared sounds like area to me. When I need the circumference, I'll just use pi d. Okay, but it's a semicircle, so for a semicircle then we know that this bit is going to be pi d divided by 2. Okay, so we know that is what the question is kind of talking about. So in other words, how much will it cost? So the total cost is 28 plus 180 for each day's work. Okay, takes 3 days. Okay, so for 3 days work we know it's going to be 3 times 180, so that's £540 so far. And the fence itself, so the fence length is going to be pi times 50, because the diameter of the circle is all the way across, divided by 2, plus the 50 for the bottom bit, because this bit is your pi d divided by 2, and this bit is the extra, so you have to add on the 50 because it wants the fence to be all the way around. Okay, so we know then that we've got 50 divided by 2 is 25, so we've got 25 pi plus 50 metres. Okay, so because that's the exact length, I've not calculated what 25 times pi is, I don't need to. It's saying that we want to work out the total cost per metre of fence. Okay, so we actually do need to, because we need to know the metres of fence. Alright, so 25 times pi. Okay, save me trying to decide where the pi button is on this calculator. There it is. So 25 times pi plus 50 equals, okay, so 128.5, so need 129 metres. You can't go to a shop and buy points of a metre, they won't sell it in that sense. So we then do 129 times the 2986, so 129 times 28, so 129 times £29.86, so 3851.94. So the total cost is going to be 3851.94 plus the 540 labour. So add on the 540. So we end up with £4,391.94. Okay, so that's the cost of doing the job, £4,391.94. Expensive job. Okay, so here we've got a question involving the laws of indices. So it's asking us to simplify this. So when we're timesing with the same bases, we add the powers. So this becomes m to the power of 3 plus 4, so m to the power of 7. Okay, so simplify means we've got to expand this, and you've got lots of ways of thinking about this. Cubing is telling you to do 5np cubed times 5np cubed times 5np cubed. That's what the cube is saying to do. Do the bracket 3 times, multiply together. 5 times 5 times 5 is 125. N times n is n cubed, times anything by itself and by itself again is cubing, n cubed. And here we've just got to be careful, because we're timesing with the same base of p, we just literally add these powers up. So 3 plus 3 plus 3 is 9, so it becomes p to the power of 9. Okay, that's one way of doing it. The other way of doing this is to recognise that in the bracket you've got 5 to the power of 1, n to the power of 1, p to the power of 3, and they're all being raised to the power of 3. Now there is a rule for laws of indices that says that if you if you do a power to a power, you times the powers. So this is the same as 5 to the power of 1 times 3, n to the power of 1 times 3, and p to the power of 3 times 3. Well, 1 times 3 is 3, 1 times 3 is 3, 3 times 3 is 9. And then we've got to realise that 5 cubed is 125. That's the only problem with that, is you've got to remember to finish off simplifying so we don't leave the cube there when we can actually work it out. So 5 cubed is 125. So that's a way of doing that question. This one's asking you to simplify by using the division rules. So 32 divided by 4 is 8. Q to the power of 9 divided by q to the power of 3 is 6, because 9 take away 3 is 6, and r is power 1, although it's not written. There's always power 1 when you've not got a power there. So 4 to take away 1 is 3, so r to the power of 3. So here we're using the law where if you're dividing by the same base, q is the same base, you can take away the powers when you're dividing. Okay, so those would be the answers to those questions, guys. Okay, so we've got a question here that says find the lowest common multiple of 40 and 56. Well, multiples means that you're going to be writing out the times tables if you want to do it that way. So we could write out the 40 times table, 40, 80, 120 and so on. We could write out the 56 times table, so 56, 112, 168 and so on. But we could see that we could be writing these out quite a lot. So you can do that as a method, and eventually one of the numbers will be the same in both lists. There is another way which, although these numbers are quite small, but it does tend to be the best way of doing it. So 40 breaks up into its product of primes by doing 2 and 20. Choose prime numbers that go into the numbers. Prime number 2 goes into 20 10 times. 2 goes into 10 5 times. So we've ended up with prime numbers at the end of each branch. So we know that 40 is made up by doing 2 times 2 times 2 times 5. And 56, we do the same idea, divide into the 56 by a prime number. 2 goes into 56 28 times, 2 goes into 20 14 times, 2 goes into 14 7 times. All of those are prime numbers. So we now know that 56 is made up of 2 times 2 times 2 times 7. Little quick Venn diagram then for 40 and 56. In the middle here we put what's the same in both lists, so we can see that we've got a 2, a 2 and a 2, a 2, a 2 and a 2. On the outside of the 56 circle we're left with 7, and on the outside of the 40 circle we're left with 5. And the lowest common multiple is all of the numbers in the Venn diagram multiplied together. So 10, 20, 40, 280. Okay, so if we carried on this list we'd find 280 in there, and if we carried on this list we'd also find 280, and that would show us that the lowest common multiple is 280. Okay, so that's what you can do to get the answer to that question. This one says write down the highest common factor of A and B. Well, let's have a look. A and B, and for A we can see that this is A is 2 times 2 times 2 times 3 times 5, because 2 cubed means that. For B it's 2 times 2 times 3 times 5 times 5. Okay, so in the middle you put down what's the same. So we've got a 2 and a 2, a 2 and a 2, a 3 and a 3. So 2, 2 and a 3. And on the outside we'd be putting 2 and 5 for this one. Actually we've got a 5 the same, haven't we, as well? Okay, so we put a 5 in there. So we've used that 5, so there's only a 2 left. And from this list we've used the 2, 2, 3 and 5, so there's only a 5 left. Okay, so the highest common factor comes from multiplying what's in both lists, so it's basically where the overlap of the circles are. So the highest common factor is 2 times 2 times 3 times 5. So in this case 4, 12, 60. So the answer to this question would be 60. There are other ways of doing this. You could say to yourself that 2 squared will definitely go in there, 3 is definitely in both, so 2 squared and 3. 5 is definitely in both, and therefore you could have multiplied those, which would have given you 60 as well. So there's lots of ways of looking for the highest common factor. Common means same in both. Factors, well, they tell you that these are the factors of the numbers, and common, well, you just go through, don't you, and find them. Okay, so this question says we've got a line drawn, it's a straight line. So as soon as we see that, we should be thinking y equals mx plus c. And we should be thinking what that's telling us about. It's telling us that when x is 0, the line crosses the y-axis at c. And if we choose 2 points on the line and we calculate the gradient, so the change in the y-coordinates divided by the change in the thing, so m equals the gradient, that equals the change in the y-coordinates divided by the change in the x-coordinates. So as terms of a rule, it's the takeaway of the 2 y-coordinates divided by the takeaway of the 2 x-coordinates. So on here then, we can see that the line crosses here, so that's telling us that c must be worth -6. And the gradient, well, I might as well choose these 2 coordinates, and we can see that this one has a coordinate of 2, 0, and we're going to be taking away this coordinate, which is 0, -6. This is going to give me my delta x, so 2 take away 0 is 2. This is going to give me my delta y, so 0 take away -6 is +6. So the gradient is equal to, delta y over delta x, the change in y divided by the change in x, so that's 6 divided by 2, which is 3. So when we go back to our y equals mx plus c is the general equation of all straight lines, so it's going to be the y values are found by doing the gradient of 3 times the x values plus -6. Well, we tidy that up by saying plus or minus makes a takeaway, so it becomes 3x take away 6. So our answer is y equals 3x take away 6. We should check, of course. So if we choose this coordinate here, we know that when x is 1, y should be -3. So y equals 3 times 1, take away 6, which equals -3. So our check's worked. Okay, so that's how that kind of question can be done. It's talking about the line and it's talking about working out its equation. So as soon as we see a straight line, we should be thinking of y equals mx plus c. We should be thinking of that little aide-memoire, which should be copied down when you're doing these questions to remind you what you're doing. Learn that pattern. And then we just find our 2 coordinates, take them away from each other, do the x coordinates away from each other, do the y coordinates away from each other, being careful to recognise. So we've got here a takeaway of a negative, so it means you're adding instead. So we end up with 6 here, and do the division to get the gradient. And that's how that question could have been done. Okay, so we've got somebody buying a van for plus VAT at 25%. She pays a deposit. She then pays the rest of the cost in 12 equally monthly payments of. Find the ratio of the deposit and the total of the 12 equal monthly payments. Okay, so this is telling us to do a calculation. It's a calculator paper. So it's plus VAT, so it's going to be 8,500 times 1.2. So £10,200. So that's how much to pay. She's paid 12 times £531.25p. So 12 times £531.25p, so £6,375. And therefore the deposit must have been the 10,200 take away the actual payment she made, So 10,200, take away, using the answer key, because obviously that remembers what the last thing was, so £3,825. So our deposit was that, and we've got to give our answer in the simplest form. So basically it says give the ratio of the deposit to the total of the 12 equal monthly payments. So it's deposit to equal payments, so it's 3825 to 6375. Now, little trick. If you want to do these kind of things and you don't want to have any fuss, it's a calculated paper, so put it in as a fraction. So 3825 over 6375, and your calculator should cancel down when it's possible. So 3 over 5. So the answer is 3 to 5. Okay, so you can use your calculator to do it for you. Use the fraction key and it'll cancel down. If you don't know that method, or you don't like that method, then of course you could have the hassle of dividing through. So here you would divide by 25, because you can see that both these numbers end in multiples of 25. So divide by 25, get that answer, and you can keep dividing by. But as it's calculated paper, guys, I would use your fraction key and it'll cancel things down for you. Alright, so here we've got to draw a graph, and it's telling us that it's a power 2 graph, so we should recognise that that's going to be a quadratic. It's going to be a U shape where that's going to be -6, the constant at the end, and it's going to be a quadratic. So we know what shape we should expect the graph to look like. It's just a case now of getting the numbers. So it's a calculated paper, so on your calculator then you'd be doing the y value is equal to, substitute with a bracket, so it's going to be -2 squared. Always substitute with brackets, guys. Really important on calculators to make sure that your calculators do things carefully. Take away 6. Okay, so bracket, make sure you're using your negative key. So on most calculators you'll find there's a little bracket with a minus sign in the middle of it, which is actually a negative. So it's going to be -2. Close the bracket. We're squaring. Then taking away another bracket, put in our negative value. Close the bracket, and then we're taking away 6. Okay, so that's what your calculator should look like. And then you press enter, and it'll tell you the answer is 0. And then for the next one you do the same thing, except this time you're going to replace the bracket with -1. Okay, now on most calculators you shouldn't have to type all that in again, because all you should be able to do is use your arrow keys and go back into the function. In this case it's not going to do it. Okay, so for me I'll have to type it in, but on most calculators you should be able to go back in and I just had to clear all the calculators I've done in the past. Right, so -1 squared, take away -1, take away 6, so -4. Okay, and then the next one is going to be 1 squared. Now this is positive, so I can just do it. 1 squared, take away 1, take away 6. 1 take away 1 is 0, and take away 1, take away 6 is -6. 2 squared, take away 2, take away 6, so that's 4, take away 2, take away 6, which is -4. And then we've got 3 squared, take away 3, take away 6, well 9 take away 3, well that's 0. Okay, so what can give us confidence that we might have done that correct? Well, because we know it's a quadratic graph, a U shape, then we have the idea that it should have a line of symmetry, so there should be corresponding values either side that work. So we can see here we've got a pattern. We've got 0, 0, -4, -4, -6, -6. That should give you confidence that you've got that symmetry going on. Okay, so now you've got your values, then you plot them. So we got -3, 6. We've got -2, 0. We've got -1, -4. We've got 0, -6. We've got 1, -6. We've got 2, -4. And we've got 3, 0. Okay, so there's our points. Now what we should remember is that this has to be a U shape, so don't make the mistake of just drawing straight across from there to there. you must have a U going on. So we kind of ghost what we're doing, just to kind of give us a feel that we might be drawing it correctly. So it's a U shape, and then we put our pen down, and then hopefully by drawing carefully we go through all the crosses. Okay, so that's what that question would have expected. To calculate the coordinates, to plot them, and then draw the shape, remembering to be really careful that you get a kind of a U down the bottom here to make sure it's got that curved effect. Okay, so that should give you the marks. And the question went on, and it says use your graph to find estimates to when this happens. Okay, so when that happens, we have our graph, and it's asking us to find when is the answer -2. So we can see that -2 would happen here, and it would happen here, because that's the graph we've drawn, and it wants to be equal to -2. So literally we come up to our curve, up to the x-axis, and we read off our answers. So the answer to this will be x is equal to -1.5 or x is equal to 2.5. Now, as long as you've shown your method, guys, and you've been very clear about your method, the examiners give quite a bit of leeway on this to give you the marks. It's more about have you got the correct method for solving it than being totally accurate. So as long as your curve and you've come up from where it says -2, as long as you've done that, then you will get the marks. Okay. Alright, so the next question talks about pressure, and pressure is one of the few formulas they'll now give you in the exam. So this one has given you the fact that pressure is equal to the force over the area, and it's telling us that a force of 70 newtons acts on an area of. The force is increased by 10 newtons, the area is increased by that. Helen says the pressure decreases by less than 20%. Is she correct? Okay, so we need to work out what the force was then. Oh, the pressure, sorry. So the original pressure was 70 divided by 20, which is going to be 3.5 newtons per square centimetre. She's going to increase by 10 newtons and the area by 10. So the new is going to be 80 newtons divided by a new area of 30. Okay. So 80 divided by 30, so 2.6 recurring newtons per centimetre squared. And Helen says the pressure decreases by less than 20%. Alright, so we need the percentage. So the percentage is always a fraction times 100. All you've got to think about is what are the two numbers? Well, on the bottom is always the original amount. So the original amount was 3.5, and on the top of the fraction is the change in whatever you're talking about. Well, we're talking about the change between the original and the new. So we're going to have to do 3.5 minus the 2.6 recurring, which is 0.83 recurring. So we divide that by 3.5 and then we times by 100. So 23.8. Okay, so we can see that the pressure is decreased by 23%, and it says the pressure decreases by less than 20%. Is Helen correct? You must remember to finish off. So you're going to basically finish this question off by saying, no, Helen is wrong. It decreased over 20%. Okay, so that's how that question could have been done. Okay, so the question here is telling us we've got a triangular prism, and it says work out the volume. So guys, you need to learn your formulas. So the volume of a prism is equal to the area of cross section times the length. Okay, so we can see in this question that the area of cross section is a triangle, because the cross section is what goes through the whole shape and is the same at either end. So that triangle would be the same wherever you cut it across this length. So we know this is the thing. So we need the area of a triangle. So we know that the area of a triangle is equal to a half base times height. And what we've got to remember is that the base and height have to be measured at 90 degrees. So in this question, yes, they've given us the perpendicular height, but they haven't given us the base length. But we recognise it's a right angle triangle. So we've got a right angle triangle where we know that's 7.2, we know that's 8.4, but we need to know this length here. And what that shouts out at us is we're going to use Pythagoras' theorem. So Pythagoras' theorem says if you take the two short sides and square them, add them together, it will equal the longest side, the hypotenuse squared. So we need to remember that Pythagoras works on the basis that that is C. That is always the longest side opposite the right angle. So we fill in the numbers that we know. So we know we've got 7.2 squared. We don't know the other short length, but we do know it equals 8.4 squared. So b squared is going to be 8.4 squared. Subtract the other one, and because we want the actual length, then we must square root, because we know what the square of it is. We'll square root it. So we're going to do the square root of 8.4 squared minus 7.2 squared equals, so 4.33. So 4.33 centimetres, because it's talking about centimetres. Okay, so 4.33, you don't need the whole of that number. 2 decimal places is fine for the accuracy, because these were all 1 decimal place numbers, so you're just going slightly beyond that accuracy, and that's not a problem. So we now need to use that formula for volume. So the area of the cross section is a half times the base length, which was 4.33, times the perpendicular height, which was 7.2, times the length of the shape. Well, that was the length, because the face is transversed across there, the cross-section area. So I'm going to times by 18, which will give us an answer of, so we've got 0.5 times 4.33 times 7.2 times 18 equals, so 280.584. We recognise the question wanted the answer to 3 significant figures. So that means we're going to find our first non-zero digit, so that's our first significant figure. We're going to cut the number there, that's halfway up, so I'll change that to a 1, so it's 281. So the answer to this question is 281 cubic centimetres. So that's how that question could have been done, by calculating the volume of that prism. And that was the last question of the paper, guys.